Hi everyone, Kevin here with Lab Worksheet 12 on testing phenolic compounds by spectrophotometer. We've got two videos in this topic. Let's talk first about what's the big deal with polyphenolics. Well, we talked about them when we talked about wine chemistry, but remember they play roles in aroma and taste and flavor and body and texture. Most importantly, they give wine its astringency. That provides that drying sensation you find in your mouth, but it also comes with a fuller body in the wine. Sometimes you get some bitterness out of phenolic compounds as well. Phenolic compounds are also responsible for color in red wine. They are the compounds that turn brown eventually when they get oxidized, but they're certainly important, right? Because they provide the color. So we often divide polyphenolics into two classes: the tannins, which we think of as providing much of the body and the astringency, and then the colored compounds, or the anthocyanins, that provide the color and also provide some body as well and some mouthfeel. So all these polyphenolics are antioxidants, so they preserve wine because they can absorb oxygen. They give wine some oxygen carrying capacity. They also fortunately serve as antioxidants in our bodies. So they're antioxidants in the wine, they absorb oxygen, but they're antioxidants in our bodies too. So if you've heard about oxidative stress as a potential health hazard, you know that when you drink wine, the polyphenolic compounds in the wine serve as antioxidants in our bodies and help us resist oxidative stress. So they're a big deal. Winemakers spend a lot of time thinking about how to optimize polyphenolic levels, and we talked about that more in lecture. Concentrations of polyphenolics. This is some nice work done back in a paper in 2002 by Andy Waterhouse from UC Davis. And in this chart, they looked at the averages of some white wines and some red wines, both young wines and aged wines. And look at the bottom here, total of all phenolics, about 200 milligrams in the case of a young white wine. In the case of one that's aged, about 285 milligrams. The difference being that the aged wine was aged in oak, and so there were some tannins extracted from the oak that add to this total phenolic content. So, all right, so about 0.2 to 0.3 grams, or 200 to 300 milligrams. Red wines have a lot more polyphenolics because we age in contact with the skins and we extract from the skins and the seeds lots of polyphenolic compounds. So the total of all phenolics, and we often use polyphenolics and phenolics somewhat synonymously, but we're looking at about 1.7 grams or 1,700 milligrams. All right, so compare 1.7 grams of phenolics here in the upper right in this slide to the amount of acid in the wine, say around 6 grams. Residual sugar, say around 2 grams if the wine's dry. Ethanol, around 14%, turns out to be about 100 grams per liter. So phenolics, it's a low number. A little goes a long ways, but it's still in the ballpark with residual sugar or acid in the wine. There are lots of ways we can analyze phenolic compounds in wine. You can send your wine out to ETS, for example, and they'll send you a nice report like the one shown here. And they'll give you a spider plot that will will compare different wines. In this case, there was an experiment done where a wine was treated with an enzyme versus a control. And the spider plot shows you on each of these axes the amount of each component in the wine. So catechin is further out here. The blue line's further out on the scale, meaning the enzyme-treated wine had more catechin. It also had more epicatechin, more polymeric phenols, etc. And when you get this report from ETS, they'll give you a little guide to what all these mean. And we've talked about some of these in a lecture in this class. And you'll see some of the things here on the left that they analyze. So they'll give you a nice analysis of phenolics. And there is a close-up of the spider plot. It tells you a little bit in this slide, and you can read through the text on the right Tells you a little bit about why we measure some of these different constituents. These are all different phenolic compounds. You can send out similarly to Vinquery or Enartis for us up in Windsor, and they'll do a phenolic fingerprint. Similar report to what you get from the ETS lab, which is over in St. Helena. And you can look through this. There are some easy ways to test phenolics in the lab too. One is to just do a jar test. You break the grapes open. You might heat them up and add a little alcohol. This would be mimicking extraction during fermentation when alcohol is produced. You might even add some enzymes that will break down some of the pulp or the skins. And you can soak overnight, so it's a quick test overnight, and you look at color. You can see how dark the solution is after overnight soaking. This tells you, hey, if it's pink, yeah, your grapes are probably not ready to harvest, right? Not enough color, not enough extractable color. If it's nice and deep red, it gives you another indication maybe it's getting close to time to harvest. You can also do measurements in the spectrophotometer that'll tell you a little bit about the color and the tannins. We're going to do those measurements today. Another way you can test is using the spectrophotometer. This is done by Steve Peck down at J. Lohr Winery, the winemaker at J. Lohr. And he'll do two tests. One is color density, and we'll do that in the spectrophotometer today. This would be the sum of the total color in the wine. And then he takes another measurement by spectrophotometer and gets what he calls the tannin index, which is really a measurement of the total phenolics. And then he does a ratio, the softness index, which is color density times 10 divided by the tannin index. And you see that here. This is an excerpt from one of his reports. So color density of 10.37 times 10 would be 103. And divide that by 46 and you get 2.25. He looks at this and calls it softness index because the color comes from the skins, and we tend to think of this in a couple ways. One, the extraction from skins is softer phenolics, oftentimes larger phenolics that are softer than those that come from the seeds. So looking at this ratio gives some idea of softness. Anthocyanin levels, or the color compounds, also tend to give us nice mouthfeel and more of a softer mouthfeel and less of that harsh drying sensation in your mouth. So he looks at this tannin index, and on the next slide, he looks at this over a number of days. You can see it from the 17th of October in 2012 on the far right up to the 22nd of October. And you can see how things change, so you can monitor fermentations and watch the extraction of color and the extraction of tannin. You can graph it out like this, and you'll see that the softness index, the color density divided by tannin, by the tannin index, is this purple line at the top. And you see it kind of peaked here at day 2. Well, that makes sense because color tends to get extracted early in fermentation. It's more dissolvable in water than it is in ethanol. Tannins, the yellow line, tend to get extracted later in fermentation. So you see that color kind of reached its peak at day 2. Tannins keep going up. Thus, our ratio of color density to tannins actually peaked about day 2. So you might be getting potentially harsher phenolics or more astringency coming out as you get more tannin, but your color remains relatively flat. So you can use this as an indication of when to press your wine, your fermenting wine, or potentially your completed wine, finished fermentation, in other words, when you can press it off the skins. Steve Peck shows a graph where they, over the number of years as they monitored this softness index, made some changes in when they pressed off this particular lot of Merlot. Or I guess this is actually a sum of their 50 plus tanks per year, as it indicates at the top. So they've pressed off earlier and earlier. This is days to pressing from the start of fermentation. So they're down around 4. They have Merlot that has lots of tannins. So they found that up here when they were pressing off at 8 days or even 11 days, the wines were huge. Consumers often expect tannins to be a little softer than Cabernet. Steve Peck says these tannins, these Merlots were bigger than Cabernet, and because of consumer expectations, they wanted to soften the wines a little bit. And by looking at the color, the softness index, they started to press off earlier. So this is one way you can use the tests of phenolics. Okay, that's our background. In the next video, we're going to look at how we're going to test phenolics in class. Thanks for watching.